And this video goes over how to find the equation of a trig function based on its characteristics. So we are just looking at identifying the characteristics here. So your amplitude is always the distance from your center, or the equation of the axis of your trig function, all the way to the top. So this value here is my amplitude, or my A value. I'm going all the way from 1 to 3, so then my amplitude is 2. So I can also find this by doing the maximum minus the minimum divided by 2. My maximum value is 3 here. Take away -1, which is 4 divided by 2, which is just 2. So graphically you can draw, or you could use the equation. The period is the length of time to complete one cycle. So I'm using my red here to mark that this is one full cycle of my graph. It starts at pi over 3 and then goes to pi. So my period is just the difference between those two, or the total distance between those two, which is 2 pi over 3. There is no reflection here. I'm basing this off my sine graph. Sine goes up to a maximum first, as does the graph that is here. My phase shift, this is like my horizontal shift. Use green for this one. And that talks about how far my graph has gone off of where my starting value is. So normally, this value here that I've circled starts right at x equals 0. It's moved by pi over 3 to the right. So that is my phase shift. And then my vertical translation is that blue line, which use some purple here, is how far up my equation of the axis has gone from where it's supposed to be at y equals 0. So in this case, I've gone up 1. My range is going to go from my smallest x value to my largest x value, which is down here to up here. So I've got from -1 to 3. My increasing values are the values where my graph looks like it is climbing. So that is, I'm increasing from pi over 3 to, this would be pi over 2, I think. And then we are also increasing from pi over 2 to pi. And then we're decreasing in between those intervals. So from pi over 2, we look like we're sliding down all the way to 3 pi over 2. Here. So let's just check those values. This would be pi over 6. This is 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, and then 6 pi over 6. So that tells me that my intervals are, so pi over 3 to pi over 2. And then this one right here, this should be 5 pi over 6 to pi, and then pi over 2 to 5 pi over 6, just using the information that I'm given to make sure that I've got the right values on my x-axis. So let's do another example with cosine. So this time our amplitude here is going to be, we've got our maximum value and we've got our minimum value. My middle point of the graph is actually right here. So if I count those squares, I know that each square represents a third. So I can say graphically that my amplitude is 2/3. I can also use the formula max minus min divided by 2 to figure out what that value is. The period is going to be the distance from my beginning value right here and over to my end value, which looks like here. Now we're doing in thirds. So this is like pi over 12 minus 2 pi over 12 minus 3 pi over 12, then minus 4 pi over 12, which would be a third. And then this would be minus 5 pi over 12. On the right-hand side, this part right here would be, let's see, times 4. This one is 8 pi over 12. So if I keep going, I've got 9 pi over 12 is the next one. And then finishing at 10 pi over 12, which would be the same as 5 pi over 6. And then I've got minus 5 pi over 12. So I'm looking for the difference between those values. So my period is going to be, I'm actually going to change that. So I've got 10 pi over 12, take away 5 pi over 12, which means that I get 15 pi over 12, which I can reduce by dividing by 3, which will give me 5 pi over 3 as the period. When I do the reflection, I'm taking a look at my beginning value, and I'm looking to see if it matches the same pattern that my parent graph does, that cos x does. Normally, cos x starts at a maximum. This one is starting at a minimum. So we would say that yes, there is a reflection. The phase shift is looking at the first value and seeing how far away it is from its original starting point on the y-axis. This one, it's gone minus 5 pi over 12 to the left. And I should just say that this is 5 pi over 12 to the left. My vertical translation is how far down this axis is, that blue one that I drew at the beginning, how far this is down from where it's originally supposed to be, right at y equals 0. So it's gone down 3. And then my range is going to go from my lowest value, which is at minus 3 2/3, all the way up to minus 2 2/3. And my areas of increase are the first half of this function. I am climbing, so I'm going all the way from minus 5 pi over 12 to, let's see, to pi over 6. And then my decreasing, I'm going from 5 pi over 6 all the way over to 5 pi over 6. And those are two examples of identifying properties of trig graphs.